In this video, we'll look at the 5 cases for convex or converging lenses and the properties of the images created in each of these 5 cases. First of all, some terminology to be familiar with. When we're dealing with lenses, F is referred to as the principal focus. This is where rays will converge, whether they're extended rays or whether they are refracted rays, they will always converge through the principal focus. O is the optical center of the lens. F prime is the secondary principal focus. When we draw rays, we will use the secondary principal focus to help us draw our ray. This horizontal line, of course, is our principal axis, and then the vertical line drawn through the lens is the vertical axis. We use this as a guide to where our ray will actually refract. So let's start by looking at how we can draw rays going through a converging lens. The first ray that we're going to draw is a ray parallel to the principal axis. Now, rays always converge through the principal focus, so just like in mirrors, when we draw our ray, our incident ray, parallel to the principal axis, so here's our incident ray, it will go through our principal focus. Now, we can draw one additional ray that also has a parallel component to it, and that would be a ray that goes through the secondary focus. We never draw a ray through the primary focus. We only ever draw a ray through the secondary focus. So you draw it through the secondary principal focus, and this ray refracts parallel to the principal axis. Those are our 2 rays that have a parallel component to them. The third ray that we can draw is a ray that goes directly through the optical center. This is probably the easiest ray to draw. The incident ray hits the optical center, and the refracted ray simply continues along the same path. Any ray striking through the optical center will not be refracted. So this will be a very helpful ray to draw when we are discussing our 5 cases. For case number 1, we are going to put our object beyond 2F, beyond the center. Please remember that when we draw our rays will always converge through the primary, our principal focus. That means this is the principal focus F, making these F prime our secondary principal focus. Our first ray that we're going to draw is parallel to the principal axis. It hits our vertical axis, and it gets refracted through the principal focus. The second ray that we will draw is the easiest ray. This ray simply goes through the optical center. Where these 2 rays converge is the location of our image. The characteristics of the image are, first of all, the image is smaller. It is inverted. It is located between F and 2F, and the type is real because it is the refracted rays that are converging. For case 2, our object is going to be on 2F. Once again, remember, our parallel ray will always refract through the principal focus. That makes these F prime our secondary principal focus. Ray number 1, parallel to the principal axis, hitting the vertical axis and refracting through the focal point. Ray number 2 is drawn directly through the optical center, and if we did this accurately, then our image should be found on 2F. The size will be the same. The attitude is inverted. The location is on 2F, and the type is real because it is our refracted rays that are converging. Case number 3, our object is located between 2F and F. Again, these are our secondary points. Our first ray will be drawn parallel to the principal axis, and it will refract through the focal point. Our second ray will simply go through the optical center and where these rays converge is the location of our image. Our image is much larger. The attitude is inverted. The location is beyond 2F, and the type is real because it is the refracted rays that are converging. Case number 4. Our object is located on the secondary principal focus. Ray number 1 will be drawn parallel to the principal axis and will refract through the focal point. Ray number 2 can be drawn directly through the optical center. Each refracted ray is parallel, so in this case we will get no image created. They will never converge. And finally, case number 5, our object is located between the secondary principal focus and the optical center. Ray number 1 is parallel to the principal axis through the focal point. Now what's going to happen here is our refracted rays are actually going to diverge. So I'm going to extend my refracted ray backwards. Ray number 2 will be drawn through the optical center. So here you can clearly see they are diverging, which is why we are extending them backwards, where our extended rays converge will be the location of our image. Our image is larger, it is upright, the location is same side as object, and the type is virtual. It is virtual because it is the extended rays that are converging. These are your 5 cases for converging or convex lenses.